Okay, welcome to Chapter 5. Here we're going to work on the math of calculating the price elasticity of demand. As you can see here, this is from your PowerPoints in the book example, and it's calculating the price elasticity of demand over this demand curve. Now, when you do this, you select 2 points. You always do this over a region. The price elasticity of demand can change depending upon where on the demand curve you are. So here we're calculating it between points A and B. Okay. Now, I'm going to switch over. I'm going to show you this using my notepad here. So give me a second and we'll get you going here. Okay, here you can see we're calculating the price elasticity of demand, and the first thing I've got up here is the equation. The price elasticity of demand is equal to the percentage change in quantity demanded divided by the percentage change in price. Now, normally when we calculate a percentage change, we would take two values. Say here, we're going to calculate percentage change in quantity demanded. So we would go from 10, quantity demanded is 10 at point A, and go to point B where it's 20. So here, I take 20 minus 10, 10 minus 20, and I would put that over the original value 10. So if we're going from A to B, 10 minus 20 is negative 10 over 10. Now that doesn't work because if we move up or down a demand curve, if we went right back from B to A, here we'd have 20 minus 10 over 20. We get different answers. So we use what's called the midpoint formula. The midpoint formula, we take the difference in the two quantities, so 20 and 10 here, and we divide it by the average of the two quantities. So here's 20 plus 10 divided by 2. So that would be 20 minus 10, which is 10, over 30 divided by 2, which is 15. We get 2 over 3 as we moved up the curve here for quantity demanded. Now, we do the same thing for price. We take P2 minus P1, because we're calculating the percentage change in price, divided by the average of the two prices, P2 plus P1 over 2. So in this case, P2 would be 20 minus 30, which is negative 10, over 20 plus 30, which would be 50. Then we would divide that by 2 and get 25. So I got negative 10 over 25. One of the nice things about this formula is we've got these divided by 2's here. And because of that, we can cancel them out. They cancel out. So that makes a much simpler equation. Quantity demanded at point 2 minus quantity demanded at point 1 over quantity demanded 2 plus quantity demanded at 1. So in the top, for quantity percentage change in quantity demanded, because we can get rid of those negative 2's here, we got this difference between the quantities over the sum. The difference over the sum for quantity, that goes in your numerator. Then in your denominator, we get the difference over the sum of the two prices. That makes this formula easy to remember. So you got to remember percentage change in quantity demanded over the percentage change in price. We take the absolute value of that. Then when we calculate it, it's the difference in quantities over the sum of the two quantities. That's in your numerator. The difference in the prices over the sum of the prices, that's in your denominator. The next step, step 2, is we're going to identify those 2 points and write their names down. Point 1 is 10 units of output, comma, $30. Point 2 is 20 units of output, comma, $20. So we've got these 2 points identified, and we're going to put them in a matrix, just like we did when we calculated the slope of a demand curve. We're going to make another matrix. The difference for the matrix is, oops, where'd it go? Sorry, lost my page. My fingers aren't working today. Here we are. There's my matrix. Here, point 1, we had 10 units of output and a price of $30. And you can see that here. Then, point 2, we dropped the price to 20 and we had 20 units of output. There is my formula. Now we're going to plug and chug. Step 4, that's step 3. Step 4, plug and chug into our formula. So quantity demanded 2 from my matrix is 20 minus quantity demanded at 1, which is 10, over quantity demanded at 2 plus the quantity demanded at 1. That goes in my numerator. We're going to take the absolute value of all this. In my denominator, I have P2, which is 20. It's hard to do this when you're watching TV. 20 minus price 1, which was 30, divided by P2 plus P1. So doing, and then it goes in brackets, it's in our denominator. So going back up to our numerator, 20 minus 10 is 10, divided by 20 plus 10, which is 30, over 20 minus 30, which is negative 10, divided by 20 plus 30, which is 50. So real quickly here, we can see we can cross these zeros out. And I've got 1 over 3 over negative 1 over 5. Take the absolute value of that. If you have a fraction divided by a fraction, you can invert and multiply. So we're going to take 1 over 3. We take the denominator, we invert it and multiply. 5 over 1, and I've taken the absolute value of this. I got rid of the negative sign. That is equal to 5 over 3, or 1.67. That is greater than 1. Therefore, we said that this is price elastic, or we have elastic demand. Okay, elastic demand, because the price elasticity of demand is greater than 1. Now, when the price elasticity of demand is greater than 1, we're going to go back to looking at the PowerPoints here. So we're going to fix that. Okay. When the price elasticity of demand is greater than 1, going back here, then we have elastic demand. Now, one of the interesting things about elastic demand is that when you have elastic demand, there is an inverse relationship between the price of a good and total revenue. So as the price of the good goes up, total revenue for the firm will decrease. As price goes down, total revenue will increase. And that's because total revenue is equal to price times quantity. So here, if we got a negative 10% change in price, that would correspond to a positive 16.67% change in quantity demanded. This is bigger than that. Therefore, total revenue would go up. Okay, welcome back here. Price elasticity of demand less than 1. When it's less than 1, we say that we have inelastic demand, quantity demanded is not very responsive to changes in price. So here I've got 2 points. This first point here, which is 10, $30. So 10 units of output are demanded at a price of $30. Point 2 here, I've got 14 units of output demanded at a price of $20. So step 1, we're going to write down our equation. Price elasticity of demand is equal to sum of quantity demanded divided by, the difference in quantity demanded divided by the sum. That goes in the numerator, divided by the difference in prices divided by the sum of the two prices. That goes in the denominator. Okay, now we're going to make our matrix. Step 2, my fault. Identify the 2 points, which we already did. Okay, 10, 30, 14, 20. Now we're going to write our matrix. So quantity demanded at 1 is 10, price is 30. Quantity demanded at 2 is 14, as you can see here, at a price of 20. Now we're going to substitute in, so that's step 3. Step 4, plug and chug. We're going to substitute values into our equation. Q2 minus Q1 over Q2 plus Q1. That goes in my numerator, divided by P2 minus P1 over P2 plus P1. That goes in my denominator, and then I'm going to take the absolute value of that, and that's equal to the price elasticity of demand. So Q2, using my matrix here, is 14, minus Q1, which is 10, over Q2 plus Q1, there's in my numerator, P2 minus P1 over P2 plus P1. P2 is 20 minus P1, which is 30, divided by P2 plus P1. That goes in my denominator, and I'm going to take the absolute value of that. So here I'm going to get 4 over 28 divided by negative 10 over 50. And we're going to take the absolute value of that. I'm going to skip to the next page. So we've got the absolute value. Sorry. Oh, gosh. Looks like a car wreck going on. So we've got the absolute value of 4 over 28 divided by the absolute value of negative 10 over 50. First thing we're going to do here is simplify and take the absolute value. The absolute value of 4 over 28 is 4 over 28. I can divide top and bottom by 4. So I've got a fraction of 1 over 7 on top. I can cancel those zeros out here. 1/5, I'm going to take negative 1/5. I'm going to take the absolute value of that. I got 1 over 5. So as you can see here, I've got a fraction over a fraction. I'm going to take the first fraction, 1 over 7. I'm going to multiply it by 1 over 5, but I'm going to invert and multiply. So 5 over 1, that's 5 over 7. 5 over 7 is less than 1. Therefore, demand is inelastic. When demand is inelastic, the price elasticity of demand is less than 1. This means, say for a 7% change in the price, we're only going to get a 5% decrease in quantity demanded. If we go back to the other problem we just worked, where it came out greater than 1, here, you can see here a 3% change in price would cause a 5% drop in quantity demanded. And the reason we're saying drop up here is because we took the absolute value. So a positive 3% increase in the price here will cause a 5% drop in quantity demanded. And that's when the price elasticity of demand is greater than 1. Excuse me there. And we said that demand was elastic. When demand is inelastic, the price elasticity of demand is less than 1. And when demand is inelastic, when demand is inelastic, there is a direct relationship between price and total revenue. Total revenue is equal to price times quantity demanded. Here, if we had a 7% increase in the price of the good, that would only cause a 5% drop in quantity demanded. 7% is greater than 5%. So total revenue would wind up increasing as we increase the price. So if price increases when demand is inelastic, that will cause total revenue to increase. If price drops, total revenue will drop. Direct relationship, they move in the same direction. I hope this helps you calculate price elasticity of demand on the quizzes and tests. Thank you very much. We'll have some short quiz questions. Have a good one. Goodbye.